my name is Ethan Johnson, and this is my final WX Widgets C++ programming project. So the purpose of this project is to create a neural signal dashboard. The reason why this is useful is because in studying the brain and the diseases of the brain, um, researchers use EEG signals and different neural signals to study the brain activity and how it is different in disease. So analyzing these signals quickly, easily, and efficiently is a important task for researchers who may not have the technical coding background to create a program or might not have the time to do so. So that's what motivated the project. Here, I started building off of our WX editor project and going from there. Um, I added these two num-enum types, the load LP and load spikes, and these vectors to hold the data. Um, the main components of this project is to first load the window of the um, data and then to load the actual data, the local field potential and the spikes, which are two neural signals, and then to um, analyze that data by transforming it from the voltage time series of the neural signal to its frequency components using the Fourier transform. And these different frequency bands have been associated with different neurodegenerative disease, um, and then quantifying those frequency bands in a bar graph, and then plotting the neural spiking as well. So here's the header file for that. We also have this on paint, which is used for graphing and visualizing the results. And then our compute FFT, which will be the Fourier transform. Um, and then the loading as well. For our main program, um, is our event table. And then the first main component, loading the LFP, and then the spike data, computing the Fourier transform, and then displaying those different components. So now I'll go ahead and talk about what this looks like. So, um, so I just recently built it, so it's already up to date on that. And then once you launch it, it will launch in full screen because this is the best way to see the figures. Then you can go up here to File and either load in your LFP CSV or the spike. So we have a sample here. It's just the CSV structure of the file just has to be in two columns. Um, so once we do that, it will plot the raw neural signal here. So this is the voltage time series here. So we have time and then the voltage. Um, and we can see that signal here. Then down here, we compute the Fourier transform, and then now we have this is our frequency on the x-axis, and then the strength of that frequency. Um, and each of these different colors represent a frequency band, which are associated with different cognitive states and are implicated in different ways in disease. And then we quantify those different, the power in these different frequency bands, and that's shown here as a relative percentage to the other frequency bands. So we can see what is more prevalent in this signal. It looks like delta and beta. Um, and then we can also look at our spike raster. But before we do that, we'll also notice down here, it'll show you a little status bar. So it shows that the LFP loaded and how many samples we're in there. And then we'll load the CSV. And now we can see here the spiking activity. Um, and again, it shows how many trials and how many spikes we're in. And we also see that updated down in the left-hand corner. And we see that it looks like it's spiking around 191 and a little bit over here too as well. So, and also with this project, the on paint function will update every time you resize the window or load new data. So it'll adjust to that as well. So yeah, so this project will be helpful in analyzing neural data. Um, and future works for this project would include um, adding a real-time component so researchers can see this in real time as they're recording. They want to do some sort of like closed loop stimulate experiment based on the feedback that they're getting, and also adding more analyses. There are other analyses, between different channels. You can do synchronization analyses between different brain regions. And then, yeah, those would be the main future directions for this work. So thank you.